In part 1, code requirements and calculation methods, we explained already the minimum reinforcement for brittle failure and crack control with or without specifying a crack width. We also handled the minimum reinforcement due to restraint deformation. Method 8 is based on the calculation of the total free shrinkage strain and the restraining factor. If the expected strain is known, minimum reinforcement can be calculated using the classic formula for crack width. Once again, we can rearrange the formula to obtain minimum reinforcement in function of a given crack width. The restraining factor can be put equal to 0.5, but it varies in theory between 0 and 1. The epsilon free is the strain which would occur if the member was completely unrestrained. This free strain, we call this free strain, is a sum of 3 types of strain. It's the drying shrinkage strain, the autogeneous shrinkage strain, and the temperature shrinkage strain. But for the temperature, it's only the temperature shrinkage strain due to hydration of the concrete. Eurocode 2, in the annex, there is a simple method of calculating drying shrinkage strain. It's a series of formulas with an input of a certain input. The same happens with the autogeneous shrinkage strain. And for the temperature shrinkage strain, if you have a normal concrete with no specific elements, then we will find that the total amount is 15 degrees difference, or the temperature shrinkage strain is 150 microstrain. As an example, we have to calculate the epsilon free, and for this calculation, or in order to estimate the total free strain, we need some additional input. The additional input varies from relative humidity to the age of concrete at loading, the age of concrete at the moment of the calculation itself, considered in days. Most of the time it's 50 years, so it's 18,250 days. Age of concrete at the end of curing time. Then the perimeter of the member in contact with the atmosphere is needed, the depth of the cross section, the width, and the concrete section follows from that. The class of cement and the overall temperature gradient as 15 degrees. Again, we use the same example, the same simply supported beam with rectangular section. First, we calculate the creep coefficient. It's a lot of formulas, one after the other, but at the end we arrive at 1.959 or 2.0. This takes part of the calculation of the creep coefficient. The drying shrinkage strain is just plain applying the formulas as given in the annex of the Eurocode 2, part 1.1, and we arrive at the end at 433 microstrain. The same happens for the autogeneous shrinkage strain, and the temperature shrinkage strain we already have. It's 15 degrees times 10 to the power minus 5. If you make the summary of the crack control for restraint deformation with crack width limitations and with using a restraining factor, for a crack width of 0.3 millimeter, we have seen, and we use a restraining factor of 0.5, then the total shrinkage strain was 633 microstrain. And applying the formula gives us 260 square millimeters.